I have compared him to Uncle Iroh, and I have called him a wise old man. But he also helps run some of the events at the Seattle Software Crafters. They have a lean poker lunch every once in a while that he puts on. And he is definitely one of the smartest people that I know, and he really cares about building up the people in his community. So, Jay, do you want to talk to us about the original meaning of technical debt?
Yes, I do. Hi, folks. I'm Jay Bazuzi, and I'm a software developer and technical coach. I have to tell you, I'm employed by Salesforce, but I don't speak for them. And yeah, I want to talk today about the term technical debt. This is probably a term you have used or at least have heard. I've noticed that different people have different definitions of technical debt. So let's explore that. What does technical debt mean to you? Please post some answers in the chat. I see the massive backlog list. We'll do it later tasks. Yeah, those are both familiar. Code that isn't maintainable. The backlog where tasks go to die. Shortcuts taken to get something out. The state that our code is in that requires cleanup work before we can make new changes. Cool. You're welcome to keep posting more. I'm going to continue, and there'll be more questions that will come up later as I go through this. I see code that is inelegant that needs cleaning up once we have gotten it working and deployed. Cool. I'm generally okay with all the various definitions people use. I don't want to argue that there's only one true definition of a term. However, I think that most folks are unaware of the original definition of technical debt as coined by Ward Cunningham. And I think it's important that we all at least understand what he was saying, even if our understanding has grown since then. I'm taking my understanding of Ward's thinking mainly from two places: the debt metaphor video that Ward posted on YouTube and a tweet from Ward about technical debt. I'll link to both of those at the end. There are two key ideas in Ward's original formulation that I think most people miss. The first is that Ward's default way of working is that the code is pretty much always clean and clear. It describes our understanding of the domain with high fidelity. Implementation details are hidden away, so the domain model is obvious. Names are accurate. Duplication is minimized. Dead code is eliminated, and so on. From this clean starting state, we would normally strive to keep the code clean as we work. But at some point, we'll learn some way in which the code is not as clean as it could be. There are a lot of ways this can happen. For example, we might learn something about the domain which we didn't notice before. Requirements might change, making the current domain model a misfit for these new requirements. We might learn about a programming language feature or design pattern that would have been a good fit all along. Or a new language feature or library might become available that does tedious work so we don't have to. I'd like to hear about a time when you had such an insight, where code was pretty good, but then an opportunity to improve appeared. Please post that in chat. It occurs to me I can't tell whether people are in the middle of typing or if nobody has a story like that they want to share. Oh, here's one. Thank you. I'll read these out. I had a data structure, a map that worked well for a small number of objects, but performance testing with a larger number of items showed that an array would have been better. Yeah, that one's familiar to me. We have an entire service that basically uses custom code to do the same thing as a tool one of our platforms teams builds for us. Yeah, I've been in that situation where when we started, that other tool wasn't available, but then became available. And so it was the right choice at the time, but then at some point it's no longer the right choice. Oh, this one's long. Okay, I'm going to let folks read that there, and I'm going to continue on with the talk for time. Thanks all for your contributions. So at this point, at this moment of insight, we have a choice. Do we continue to work with the design as it is, or do we go back and clean up the code based on this new insight? Ward's default behavior is to go back and update the code to make it look like we knew this insight all along. That is, we write the cleanest, clearest code we know how for the current requirements. And the moment we discover some way in which it is not the cleanest code we know how to write for the current requirements, we refactor the code to make that true again. Because we do this continuously, we're always doing it in tiny increments. There are no huge rewrites. That's the default for Ward, which I think is different from what the rest of us do a lot of the time. But maybe you can think of a time when your team made a quick, tiny improvement to the design of the code. Please post about that in the chat. See, using better Django features to remove SQL statements from our Python code. Cool. All right, I'll continue. I really like all these answers. I just don't know how to put this into the pace. So I'm going to go on. We added approval tests. Yeah, good tool. So sometimes there's business value in deferring that refactoring, even though that would create an ongoing cost. Ward talks about the value of shipping our feature sooner so we can get feedback. That feedback is extremely valuable, so it might be worth it to take on the additional ongoing expense of technical debt, at least for a little while, in order to get that feedback sooner. Note that this is an anomalous behavior. Usually, we refactor right away, but sometimes we defer the refactoring for a short time. That's taking on technical debt. Most organizations aren't able to do this small, short-term deferral. They defer design improvements and then never come back to the refactoring. At least that's been my experience in a lot of places. The way I see it, these organizations can't yet handle the responsibility of technical debt. And this leads us to the other key idea that I think most people miss in Ward's original definition. Technical debt is a deliberate strategy. It is not a symptom of a dysfunctional organization. It is not a curse left by the people who came before us. It is not a reason to throw out all the old code and write from scratch. We deliberately take on technical debt in the same way that businesses take on financial debt, because it allows us to do something valuable. So that's a bonus key idea for you, that for businesses, debt is not a bad thing. It's a useful tool that allows you to do more. The same should be true of technical debt. When you talk about technical debt in your context, think about whether you're dealing with an unfortunate mess or the results of a deliberate strategy. Remember that business-oriented people you talk to are likely to see debt in a much less negative light than you do. You might need to change how you talk about it so that they understand what you're saying. Now, all that I've said might feel very foreign to you because most code bases aren't maintained this way. Most code out there is a mess. When you're working in a gnarly mess, the idea that we would normally make the code as clean and clear as we know how just seems impossible. I sympathize, and I love working on gnarly legacy code. But how we deal with that is out of scope for today's talk. For now, I want you to understand that your context is probably not the same one that Ward was originally describing. This is a mind shift talk, not a call to action. But here are a few things you can do if you want to be more like Ward. First, change how you talk about technical debt, especially with business-oriented people. Next, in new code, start clean and strive to keep it that way as you go. If your organization, like most organizations, doesn't have the ability to promptly address deferred cleanup, don't give them the option. Don't extend the line of credit. As for recovering existing gnarly code, well, it's a huge topic, and I don't know what Ward would say. I'll say, stop digging. Don't let the code get worse with each change. We can discuss how to clean it up in some future forum. Thank you.
Thanks, Jay. I know definitely with that talk, the talking to business people differently about debt is something that is very hard for me to do. And I didn't understand why it wasn't seen as a bigger issue. And I said, we have massive amounts of tech debt in this future. Yeah, so it's a good thing to understand that shift. Are there any questions about the talk or about technical debt in general? Yeah, Forrest has his hand up.
So, you raise an interesting point. I think if we talk about, I guess, weighing the seesaw between business value and technical debt, and how you compare it to business debt, which is usually a good thing. But I guess in that sense, I come from the business world. I used to work a corporate job where the only job I did was generating business value. When it came over to the development world, it was hard to, I guess, in the lack of a better term, convince developers that business value is also important. I literally had almost got into a fist fight with a developer last year because literally, if we didn't deliver this in 4 weeks, we'd be slapped with a $20 million lawsuit. And the developer was saying, but I have to write, basically was saying, we have to write this clean or like you'll never like refactor it. But do you believe that in kind of the new era of, I guess, whatever development stage we're in, do you think that developers should learn more about the business side and understand business value and learn how to weigh business value, delivering business value through code versus like eliminating technical debt?
Yeah. So yeah, it's an interesting question. I think like the really short answer is we're here to do business. We've organized, as a business, we're employed by a business. The business has a purpose. It wants to make money. It wants to produce some kind of value in the world. Those are the reasons that business exists. And as employees, our job is to further those goals. And if I'm a developer or I'm a tester or a program manager or a salesperson, like we're all here for those goals. But you asked, do developers need to understand that? And I think there's maybe a trickier answer here, which is what's important is not whether developers understand it, it's whether they do it. So you can create organizations where a developer is very focused on, I'm going to write clean code, and somebody else figures out the relationship between that and the business goals. I don't necessarily need every single developer to be thinking about business outcomes with every single decision they make, but I do need the decisions they make to align with the business goals. So I'm willing to let that coordination, the generation of that alignment happen somewhere in between development and business, if that's what we need in this context. Now, we're sitting here talking, I would say to everybody here, pay attention to business concerns in your context. That's why we're here. And I'm guessing that you're all open and curious to those ideas and would like to learn more about them. But I wouldn't go so far as to say every single developer must orient around that all the time. I think that's too much to ask of developers, even though it'd be great if they did more of that.
Eric's hand is up.
Yeah. I'd like to add to that. In my last role, I sat in both sides. I was, a developer, and as well, I moved into the management side and into program management. And when I'm coaching teams and product managers, one of the things that I came up with and I keep on saying to them is that the product managers are responsible to make sure that the right thing gets built, and developers have to make sure that the thing gets built right. So that's, it's a good, simple way to kind of view it. So then the separation of concerns are there. Is like developers really, they need to have sort of a arm's length understanding of the business value, but the importance is on the product managers who are dealing with the client directly to communicate that properly to the developers, and then the developers will then make sure that it's getting built right, so then they could avoid long-term tech debt. But if you're running into time frame issues and those kinds of things, then those are going to be accepted risks that those stakeholders will have to take and accept, and the developers will put those in the backlog and say we need to go back and fix it.
Yeah. One thing, I don't know how clearly I said this, for most organizations, I think developers should not ask the business, should I write tests? That's not the right question. That's not a business concern. As a developer, you should understand the business goals, and you should be trying to figure out, how does tests fit into achieving those goals? To whatever degree as a developer, you're up for doing that. I think we often underestimate it, and that's on us as developers. I have this experience over and over where I think, should I do the short-term thing or the long-term thing? And then if I do the long-term thing, when will that pay off? And if I do the long-term thing, then like 2 days later, it pays off. And then 2 days later, it pays off again. And wow, that was the right choice. I had no idea going into that. It just turned out really well. So, I think we have a hard time predicting the future around that, but I don't know. I feel like I've gotten lost. Don't ask non-technical people to help you making technical decisions. Do orient around the business goals, but understand that our ability to predict the future is difficult. So tend to err on the side of clean and tested and so on.
Yeah, and just in terms of the long-term and short-term trade-off thing, sometimes I will chat Jay and I'll be like, Jay, is this a good idea? And Jay will be like, no, that's not a good idea. Do the longer-term solution. And I will decide, well, I'm my own independent developer and I'm going to do the short-term solution for this thing. And nearly every time I have wound up going, gosh, darn it, Jay was right again. The payoff that I get from the longer term solution, as long as it's not getting in the way of the business value that I'm trying to generate, usually better.
Kind of a challenge that I've been running into is, I really love and try to adhere to the idea of like creating a safe environment for our development team and for respecting the coders who came before. But if we found ourselves in a state where we're kind of in, I think you described it as an unfortunate mess, rather than deliberate technical debt, and trying to explain clearly like what this is costing us currently without harming that safety within the team has been like kind of a challenge at times.
Yeah, I've run into that problem plenty, and I really would like a tool for that, a way to say, here are the real costs of all that debt, because I expect they're 1 or 2 orders of magnitude higher than we are recognizing. And if we really knew that, that would change a lot of how we make decisions. I have a tool that works for just one part of that problem. So when you think about the cost of technical debt, part of it is I make a code change, and now to verify it, I have to do a bunch of whatever I have to know to test this thing and that thing. And a new person joins the team and they don't know that, and it's hard for them to make the right test decisions. Maybe they introduce some defects, hugely expensive. And that part I think we can measure. And then another that I think is hard to measure, just for contrast, is I open a file to try to read it and it's confusing. And how this code relates to other code in the system isn't obvious. And I don't know how to measure the costs of code readability. But the area that I do know how to measure we've been calling it toil. And by that we mean the aspects of our work that could be automated away to pretty much zero, but aren't. And that's testing a change, releasing to production, observing the health of production, doing regular maintenance like updating credentials, detecting that new third-party dependencies have updated and that we should take those updates into our system. So those are the ones that I'm aware of. And those are all things that technology exists to fully automate all of those activities. And in many projects, they're not fully automated. So I think that those we can measure, and we can measure them in ways that non-technical people care about a lot. Wow, you're spending 80% of your time on nothing of value. You should go fix that. So I'll put a link in chat for an article I wrote about that. But while I really like it as a tool, it only covers certain aspects of the costs of these kind of debt. And I don't know how to describe the rest of the costs in ways that make sense to people who aren't programmers. And I would like more tools for that.
Thanks. Mm-hmm.
That's hard to do. I'm thinking about stuff at work where I'm like, how do I measure the cost of this to prove to people it would actually be useful in investing here? And
We do have a situation where we have a really nice piece of code that we've been like practicing like our best practices on. And it was all greenfield that came out in the last 6 months or so. And when they want to make changes to that, contrasting to when they want to make changes to the older legacy pieces that we've got, just being able to point out like the difference in like our velocity when we're working in those two is really nice.
Mm-hmm.